what do we do? What we call the interior layout design. We normally also call it a interior topology, where relative positioning of your bedrooms to living rooms and the kitchen and the toilet areas and showers and all that. One of the things, obviously, guys, you may agree with me that the size of the structure, the building space, is very large compared to the typical houses of Hong Kong and highly dense populated areas like in Singapore or Hong Kong or part of China, or even my own country, which I came from originally. We used to live in smaller houses, but this one is relatively uh, uh, larger in area. So you will be kind of a little bit struggling to see what's the size of a bedroom, how much I should allocate to a bedroom, and things like that. Take my word for A and D, which are the larger footprint apartments, have a significant space for you to do a thing, and B and the two small units, relatively small units, are also big enough to do good things. So I think your work will be assessed by your teaching staff there, basically to see. You can't build in everything, but you, to a given situation, we can find what you understood it, you have used it to the best of your knowledge, and then that is a pretty good design. We feel it. We have seen many years of students coming through this path. We know what they have achieved. So it is important. It is not that you can cover all aspect of it, but you can highlight in your report, this is what I have covered, and that is what the reason why you did what you did. I also, because the students they're in Hong Kong, it is not fair for me to not to give this, because it's important to in a house like of the size I have given there. Normally, just these are not exact sizes by any stretch of imagination. You can change them wherever you want, but rough idea of what these room sizes are. So normally formal lounge and dining will be about 3.5 to 5, which is a large this thing. And I remember once one of the Hong Kong students said, "Saman, my entire apartment is something like that." So I do understand that. Normally, master bedroom will always having a walk-in robe in the modern houses, and also an attached bathroom. So AB stands for attached bathroom, walk-in robe. Master bedroom will be about, therefore I have given rough values for. So the master bedroom is 4x4. Walk-in robe can be about 2x4, and then attached bathroom can be 2.5 times 3 kind of a thing. So it's a fairly large space. Bedrooms, general bedrooms can be 3.5. Bedroom and studies 3.3. I mean, these sizes are very it's kind of a range. You don't worry too much about exact values. So basically the purpose of this particular slide is for you to just to know that. So that's a little bit of help. I'm pretty sure that you must have started and already gone a reasonable distance in that aspect as well. Okay, developing an interior layout plan and framing plan in design, I don't think this is a lot to discuss. One of the reasons I have given this set of slides, which I share with Australian students here as well, only because then you can see that how an architecture engineer, an experienced guy, would start to develop an interior layout plan, and then from that plan, how the engineering drawings are coming into play. Okay? So just to show that part. That's why I have taking you through this. Uh, so architects normally conceptual design involves developing a very quick conceptual sketch, what they refer to as a bubble diagram. Normally, we engineers like to draw straight lines and then specific dimensions at the beginning. But normally, an architect, because he likes to keep his mind free, he sketched these things like a bubble diagram, like a bubble connecting to each other. um, that's fascinating. When they do that, they get the interrelationship not restricted by the dimensions, but by the idea where it has to be located, relative terms. So these are called bubble diagrams. So that's the purpose of the next step of drawings, how they come to the final working drawings or construction drawings at the final stage. So therefore, this is an office building they are doing, office or school building. I can't remember. Should be there. I think this is an office. No, it's a school. Yes, classrooms here. Yeah, that's correct. So they call this circulation passage. So you can see that there's a word called circulation here. What does this means is, so circulation part here. This is like corridors, right, in a house. The purpose of this one is actually connecting all the necessary. This is a school, of course. Um, so so these are called normally circulation. The word architects are using is circulation. So the bubble diagram is a way of allocating sizes, and they normally use a nice graph paper kind of a thing, so they can draw it to scale. They roughly know, if they say, oh, okay, each one of these little small squares equal to whatever the dimension is, and then he or she can play with it quite easily. Um, um, Draw that. So this means free drawing here. You can, and some of the architects even use separate colored shapes, so they push around these things and then arrange it very quickly. That is called topology inside of the building, and then how the relative rooms and other things are nicely falling into the right place. For an example, if you're in a residential building, if you ask me, I normally look at the rooms and the space allocated in a slightly different way. I see them as rested areas. The others called the formal areas, which means when a visitor comes, that where they sit. So formal areas, resting areas means the bedrooms, quiet areas, which is like a reading or a library or whatever, office or something like that. And then I also see the processing areas, which means that kitchen falls into that, laundry and other areas falls into that. And the bedrooms are, of course, the restrooms. You try to locate, for an example, the TV and entertainment room, or in Australian context, you can have family areas, you can have formal areas. Formal areas means that the part of the house which is very neat and clean, and then when a visitor comes, that is where they come and sit and then have chat. But the family areas are a little bit messy. You can't keep it probably, but that is where the parents and the kids feel very comfortable and free, and so those type of relative arrangements of a building for whatever the purpose that you are designing it for is called a topological interior. The In this particular case, it's a school. I am mentioning about a home because you are designing a home. So you have family areas, you have bedrooms. Easily these spaces, you can have about 2 to 3 bedrooms easily, with a master bedroom, reasonably large master bedroom, and nice living areas, and formal living and family areas. You can have in a house like that. You can have about 2 toilets if necessary, 2 or 3 master bedroom with a walk-in room and a attached toilet, of course, there, and then the shared toilets and bathing can be in another area. So once this is being done, then only start to this grid line starting to happen, dimensions started to come into play, and at the same time, an architect would draw freehand just a elevation, how you'll see it from the sideway. So you can see the man is standing here. That indicates, so this little man, I like the architectural drawings because they draw it to scale. So there, if this man, and then this is a, of course, a school, so this space is high. But in a normal residential building, like the one that you are looking at, your floor to floor height may be about 3 meters or 3.5 meters. I must have given that in the data. I think it's about 3.5. I can't remember exact value. Please have a look at your assignment. You would know. So here is the another important factor where you can see an architect is working with sunlight, in direction of sunlight and wind and things like that. So you can draw elevation very quickly, laying on the plan. Now you can see the light color one and then the dark color one, which means that there's a tracing paper. So once the planning is done, the tracing paper will be put on it, and then you can use the same dimensions. You don't have to scale it again, and then you can draw a nice elevations, we call it. Okay, so these diagrams give you an understanding. There you go. Now the bubbles are starting to just appear like rectangles and straight lines afterwards, and then you can see that it is just getting into shape, and then you will start to see more specific diagrams from an architect. These are, most architects do this amazingly freehand. They're very good draftists. um, Freehand, not only freehand, I have worked with some other architects who actually draw to scale. Without a scale, they draw to scale, say 1 to 100, and then they they have done it so many times. So I think these are the kind of skills that I think you would start to generate if you do this project in a passionate way. It's very important. So then only the structural drawings come into play. Oh, what is the size of the beam? Is this a secondary beam? Is there a column here? Kind of a thing. But in your case, not. You have all the walls around it, so that you can really support your beams and slab through those shear walls, which are quite capable of carrying vertical loads as well as lateral loads. Okay. You can see here now the roof is being generated, and then some ideas being sketched on, again using a butter paper or a tracing paper on the original plan, and then you can do both elevations. I don't think we have asked you guys to do an elevation, but what is important is I'm showing you how a bubble diagram step by step merge into evolve into a structural drawing. So you guys are pretty good at this structural drawing part. You may not be, most of the engineers, even here and there, I have worked with so many of you guys previously. I normally come to Hong Kong because of the COVID. I can't. I come and work with you guys on these workshops face to face, sitting with you guys. But this time, unfortunately, we can't do it. Um, but it is all the time, surprisingly, engineering students always they they wanted to go into straight line straight away, uh, for some reason. um, so you're thinking about, I'm pretty sure 90% of you guys have started drawing like that. Maybe 10% would be thinking like an architect, but nevertheless, it's okay either way. It's an assignment. um, I'll quickly take you through design for deconstruction ideas. I'm pretty sure you know this. It is designed for, it's just a philosophical term. Um, All of these bright ideas come from an initial thought or philosophical understanding of what is happening. That is why we used to design for construction all the time. But in future, we will be looking for design to deconstruction as well. Construction is important, but you also have to, from a sustainable point of view, you should be able to see design for deconstruction. Okay. I have given here key points: traditional engineering design philosophy and practices focus on design for construction. Just I mentioned it. That means designers do not have to necessarily consider what happens after the design life of this design. And then you can also say emerging design philosophy means that new generation of thinking is that you have to think beyond that. Can we reuse it? Can we get component and then recycle them? Can we minimize demolition, because the dust pollution is very high in a demolition setting, but deconstruction setting it is not, because you can undo it and then take the material and stacked. I'll give you a real example how well that they have done that. So basically, what we are trying to see through this particular uh, subject is whether you get a sense of it, you rough idea. Say this is a typical 6S diagram, they call it. Stuart Brand's initial idea how you can visualize a housing sense. um, what are the things that you can do for deconstruction or reuse kind of thing. Some parts you never can, some parts you can. Site, then the structure, you can see the arrowheads, and then the services, which is water supply, sewer, electricity, ventilation, and all that. Space plan, um, and stuff, which means this inner one is basically meaning that your interior setting of the thing, and then it is. So although this six S's also, he gives a rough idea of when actually these things have to be changed all the time. Now, in his theory, some long time ago, the stuff is changing 5 to 15 years. Here, stuff means the floor carpets and the floor finishes and the repainting and all that sort of stuff. Space plan is, you can, some of the countries, your internal house interior can be reorganized, and then you demolish walls and then replan it, and then you can do it if you have your own home. Of course, if you are in a government sort of one or rented, or then you can't do it. But that is what you call the space plan, basically the requirement for the bedroom sizes and living room sizes, and then changing them as the families grow out and all that sort of stuff. Skin of the building, whatever that is, probably about 30 to 60 years. Um, and then and the structure is normally designed to 60 to 200 years in the old scale. I don't believe in future, unless it is heritage listed, a structure would survive 200 years unless it is heritage listed. um, because in the modern way the things are happening is we can very quickly change things. We can very quick, and then the designs and the styles are changing all the time. So it is rather repair and maintain. It sometimes come to a point where you can demolish and then reconstruct. But that is the part which we have to be careful of. If we design for deconstruction, because knowing that is the case, it's going to be, and then what is going to happen is it might help to uh, minimize the wastages and landfill, and it will improve the sustainability. Um, put if we do it that way. Um, I have also given here about 6 or 7 dot points, I would say, actually 8 dot points, and then in summary, what this is about, what is a DFD considers for you, your project. Um, Read these, and then when you are writing your report, also you can use some of these ideas, and then you say, okay, I have considered about this. This is how I have changed my thinking and design according to fit into one of these or two of these or three of these categories. So that is the part of learning that we all are looking for. um, I think this is pretty clear. Sustainability outcomes of DFD are minimizing embodied energy and carbon footprint, because you will be reusing them. In a sense, it can have many lifespans. Although the building has one lifespan, but the material can have another. Minimizing construction waste and landfill, we discuss about that. Making second-hand home components available, reuse as car spare parts. I just mentioned this one. Improving affordability. The people who cannot afford a house can be used those things until they can become affordable, and then having more incomes and things like that. Dust emission in demolition is a major urban concern. And the other one is the urban construction noise. Very soon, construction noise will be, there will be legislation for construction noise in most of the major cities. Disruption and productivity losses, and those type of things. Quality assurance with a controlled construction fabrication environment is far better. So if we have actually some parts being assembled, like in a modular construction, and then brought to site and fix it, that is also very clearly environmentally friendly. Improved health and safety of it. There are many cases that these demolition sites have significant consequences, and that is, it will change over the period of time. And then the most important thing is that the number of roads all the time have to be closed during heavy traffic times, because the demolition and construction happens like that. But if you're smart, major part of that can be constructed somewhere else, and then bring and connect it like the modular systems. So so I have also given which ones actually you can utilize in. I mean, if you put this as a little in a little table, if you put a tick which you have actually attempted and successfully done, you can maximize your marks. That's the idea. So I have given here a lot of information which will be useful to you when you start thinking about it. If I were you, if I'm in this class, I would just put this one into a table, and then in a one column, and the other column I'll be saying, yeah, achieved, partially achieved, couldn't achieve, and things like that, so that you have a reflective way of looking at your work, and then see whether you have improved. Um, Guys, when I was of your age, I think majority of the highs, almost all the buildings had what we call the permanent walls. All, even non-load bearing walls are made out of blockwork or bricks. Um, we hardly have ever heard about lightweight interior wall systems in large buildings. Um, that was because that was the practice. It was messy inside, and then all the water, and then the construction cycle is very long. But those days, that was not a problem. But in the modern era, speed of construction, even at extra cost, is considered good for both contractors and clients. So what is happening now is actually construction is, and this time, speed of construction is a major requirement they want to happen. So that is why this type of products starting to happen. These lightweight drywall systems have been there for, I think, about 30 years or so, but not now. It is almost very popular. That hardly any permanent uh, um, walls are required. Why? It is common sense. If you have a lightweight partition walling system, which would work as better than the bricked cemented brickwork or block work, and then you can have the acoustic quality far better than those things. And then also when you're designing your floor slabs, if you have light partition walls, interior walls, which are hopefully non-load bearing, and then in that situation you probably would be better off. And then the most important thing now, although a tall a building is constructed, say for an example office environment, and then the client will change in few years, and then somebody will come, and some company or some individual or a developer coming and buying it, and they will also remove all the interior non-load bearing stuff, leaving the load bearing members only, and then they will retrofit it or refit it completely differently, so they will change it. So the for that reason, that the drywall construction has become very popular. The drywalls can be designed to deconstruct much quicker. So it is like a paneled system of very, very lightweight material. Most of the interior walls in the modern era are done like that. So there are hundreds of products in this category, guys. I have put one which is a little bit popular here. But having said that, you can I have given here. You can download these things. Just type of products or equivalent. Just drywall construction or suppliers kind of thing. Keyword, and then you will get thousands of things. I'm pretty sure Hong Kong must be having plenty with the number of high-rise buildings that you guys have. So internal steel walls. It is steel means light gauge steel. It's not very heavy steel. Stud walls, we call it. Normally, external walls also can be light, dry wall systems, and of course, the ceiling is also very similar. So these three little things will give you plenty of details which you can use in your project submission, and then we will value that because you learn something in the system. So think about these are very important. They are very detailed. We are not expecting you all to design these internal walls per se, but you can take the detailing side of things, the dimensions of it, what's the materials being used. So you will learn a lot by going through this process, if I may say. Okay, guys, one of the best examples of the good example of a construction for demolition and sustainability was actually the London Olympics 2012. From memory. So you can see how they are layered because we know most of the stadiums, although Olympics brings 100 to 120,000 people or 200,000 people to the venue. After that, that venue can't fill in forever. So certain part of they have decided certain part of that elements can be temporary. You can disassemble and take away. Certain seating tiers, certain grandstands can be removed and then taken away. So their design philosophy was set to that. And also they said we are using design for deconstruction, and also we are using whatever the recycled parts of the building industry to put it in here so that they will get an exposure, they will get a market, the people start valuing that sort of aspect. This is a brilliant case study when you have time to do that. This is an 80,000 seats. So you can see that the site they have selected was old site, and then they have completely demolished, removed the buildings, and then put the stadium. And in that removal, they have carefully undone it, carefully taken, and then classed all the materials separately, stacked it up, and then reused those material for some proper purposes. That's the classic recycling. Recycling have two ways. One thing is that the recyclable material is brought to a manufacturing yard or a factory, and then melted it and then do something with that. The other one is the components of a particular old structure will be put in, if provided the quality is good, put back into the system, properly treated. Now this is a classic example of it. So this was a bomb site, which we normally call here in English in Australia. Bomb site means is a site. Most of the buildings are very old, and that is acquired by the government, paid for the owner, and then what they do is they demolish. And when they demolish it, they not demolished it. They disassembled it, and every beam, steel beam, every timber member, they have actually classified and then thought about how to use it, and then the rest they have discarded. So this is a systems thinking, we call it. You see it as a system, and then you apply that into your design ideas. Okay, and you guys are going to be the future engineers. Therefore, this is a good way to look at your skill base. um, you can see these pictures. These are old steel members, steel girders. Some were cast iron, some are steel. These are the timber being used. So they have acquired them, reclassify them, got got their properties checked, and then reused them. I think that was, it was costlier than getting the new one and doing it, but they have done it as to set an example for the future at a relatively high cost. And that for that we have to commend those designers and architects who had that. So basically, we are asking is, modulation and modular construction is becoming very good, and then it's part of sustainability. And then what we are trying to do is to see, hey, hang on a second, your interior walls, and most of the students in this project consider that all those concrete walls, which is shown in the on the plan, are their surfaces are as smooth. No, you actually have to have some sort of a dressing around the existing walls, because their form of quality is not necessarily very smooth, perfectly casted concrete. So you can actually, you have to dress around it so that you can get a one straight line. It is not all over the place. It is uh, eh, most of the students are just joining couple of internal walls and then use the edge of the shear walls or the dark colored walls shown, as assuming that they are perfect walls, very smooth and can be painted. Once painted, it looks very good. It is not. So what you have to do is, on those things, there is a different kind of cladding that you have to use. Of course, it is not a dry wall per se, but it is a cladding around those walls, because you can't assume that it is having a pre-stress um, status concrete finish. There are concrete finishes varies from S1 to S6 different tolerance types, and then the worst one, tolerance could be about easily 10 millimeters. They wouldn't mind, say for an example, below ground work most of the time like that. But you can't make that assumption in a building. So you have to try and find a nice detailing which goes with you. Those walls, existing structural load bearing walls, they are not necessarily perfectly smooth. The other thing is modular construction. This was a master student who worked with me few years ago has done. So our idea was, we looked at modular systems which can be put into one another and stack it, and then it can be easily transported like a telescope. You can pack one inside the other, so the geometry is perfectly done, and then using these things and then arranging in different floor plans can be generated. It is no difference. Say for an example, if you have a lottery has 10 number and 6 number lottery, um, and then you can generate each number uh, 1 to 1 to 1 up to 9 and 0, and then you can have million tickets printed on it by changing the numbers, isn't it? Similarly, you can have A, B, C, D, E type modules, and then you can have a number of those modules connected together to get completely different interior floor plans. And then also interesting thing is that if you look at the 4.12b, this was a master's project long time ago, 2002, that we had done. It's since the beginning of the modular systems. I think what happened was that this dark area, that is not a module. That is an area surrounded by modules, which means that is a positive space generated without being a module. And this may be the family and living area. This may be the bedrooms and things like that. So you try it out. This is one of the ways to look at it. So you can pack these things and put it into a container and then send off site, and then there will be house plan already in place and they could be assembled. Only downside is the wall thicknesses can be doubled because when the back-to-back modules. But speed of construction, ease of transportation, efficiency of factory manufacturing, doubling of that wall will still save. It's not a costly item at all. Okay. So you can visualize some ideas like that. So that is the whole idea of this project, guys. We have given an open-ended task. But if you do it right, I think you can learn a lot. If you think and then do your best outcome that you can think of, that would be fantastic. This is kind of a spider web graph. Rather than having X and Y axis only, that we can use many number of axes, and then we can try and see, okay, see if the dotted line is the actual one, and then the light blue one is the proposed one in general sense, comparing two designs. Say for an example, you can see air quality, if it is improved, greater air quality, the dotted line was the standard one or the past generations one, and then you would say, yeah, that is fantastic. And then you can see that embodied energy axis, the dotted line was the existed system, and then if you can reduce the embodied energy by having smarter material, smarter manufacturing methods, and then you would find that that is a better one. So basically what we are showing is once you actually done a design in future, that it can be measured on those things. Say potable water consumption is very high, say high in the older standard one, but the light blue one with the targeted design has to try and minimize it, do some savings. So this shows the blue color one and the other two shapes comes from operational energy of the old one is higher than the new one. So you can have some sort of a measure in future to say, oh, this design is pretty good compared to another one. Okay, so these type of ideas I keep coming. The flow framing aspect, guys, I think what we are trying to do here simply to say that you have already done your concrete structures. Some of you guys who are working in the industry has used your design codes, Hong Kong design codes. So this must be very easy a task. All what we are saying is your flow. We have not given where the beams are. We know it is a slab. We have shown all the load-bearing walls in dark color. So we are also suggesting, can you do a flow framing for us? Flow framing here means that it's a concrete slab. Beams can be the steel because the walls are already constructed, then therefore you can fit in if you want a beam between walls, or you can cast in a concrete floor slab. So the idea is, a complex shape. It is not a rectangle. You know how to do a simply supported beam and even a continuous beam, but most of the time it is rectangular given dimensions in, and then you do the design. But let's for once, we will try unusual shape. We will try. Nobody has told us what's the span of the beam. You will decide where the beams need to be put in, and then slab to be. What's the size of the slab? So you can start with trial sections, span to depth ratios, for an example. Um, uh, Euro code, and I'm pretty sure Hong Kong code, and most of the industry practitioners know what the span to depth ratios normally for reinforced concrete, for slabs and beams, and it's like a trial section. So you get your framing done, and then you analyze and justify your beam and the floor plate. How do we know whether you have done a good flow plate design? Because then the efficiency of the flow plate design can be measured by what is the overall flow depth, or on another way, that it can be measured by floor to ceiling height. So if you have a 600 millimeter beam, say for an example, deep beam, and if you have a 3 meter floor to floor height, and then you'll be having only 2.4 meters as the clear height between the finished floor and the ceiling. So you may ask, as a client, you may ask, "Oh, come on, I'm compromising my clear height inside the building. If it is a hotel building, it's different. You are doing a residential building. So in that situation, how we say that you have got a good, smart layer flow framing done first, so that, and then when you verify that you have very good um, flow depth, structural depth of the flow is a very good performance indicator to tell you before going through the numbers whether you have actually got the best design outcome. So that is one of the ideas of this particular exercise. Okay. So I have given here a design example, simply supported kind of setting, or continuous members also there, um, using Eurocode, how you can actually do a calculation. I'm pretty sure you guys have done concrete construction, concrete design. Many of you must have used your uh, Hong Kong standards for uh, concrete structures, even loading codes. The loading according to the Hong Kong practices. Um, so this is a simple example. The steps that I have shown, I'm pretty sure you can follow. Your figures may not be exactly the same, but this gives a rough idea of where to start and how to proceed. So I don't think I'm going to go every step along the way, because I know all the past students, they have done their concrete. They're pretty good at it. They know how to do it. But the one of the things they struggle is, if you give a blank flow plate like this geometry, and then where the supporting points are, which are the dark black lines which are representing walls, and then certain parts are cantilevering. you are struggling to develop the flow framing plan. Even before you can do the calculations, that is the part you need to be able to, at your level, frame up. You are pretty good in rectangular shapes because that is what you have trained. Now, this particular project provides a little bit of challenge because you are first you have to do to frame your structure, and then to know where is the beam, where should I put the beam for a start, how do I support my cantilevering edge slabs, and then that is uh, part of the exercise. So I'm not going to go step by step here, but if you go through, we are talking about this euro code that we have provided you guys, but you can use your Hong Kong code, Australian code, or whatever it is. Um, uh, Different codes have different ways of doing things because country to country these things are slightly different. But fundamentally, they should they should you should be using that knowledge to get the best flow framing option. You can have many options in framing a flow. Which direction is the primary beam? Where is the secondary beam? Which direction is the slab is spanning? All these questions will come to you. Flow framing, once it is done, without really doing jumping to the numbers from an argumentation point of view, with the knowledge that you have, like span to depth ratios, span to deflection ratios, those type of broad values, and then you would be looking at first qualitatively. You start to think about the problem and get the best framing proposal. Your main focus should be to have the optimized or maximized, I would say, flow height, flow to ceiling height for your house. So in order to do that, uh, you have to try and see what's the best scenario for uh, the flow framing that you can do. So if you give a flow depth, um, if I have clear flow depth, mind you that if you have beams, there should be services and other things are running as well. So you have to at least allow a 300 millimeters between the ceiling and the bottom of the beam to have the services run, especially if you have your toilet areas in your house, and then you have some or the other get the sewer lines towards that only passage where the service duct is shown. So you will see that the sewer will have a little bit of a greater slope. So if you have, rather than 5 meters, if you have 16 meters, then what does that mean is that your ceiling height will be lowered, or you have to have a bulkhead to make sure that the sewer pipe doesn't come cannot go through within the ceiling cavity, between the ceiling and the concrete above. So those type of things is the objective of this scenario. Okay, I mean this is you. I'm pretty sure you will be perfectly fine for to do a simply supported or continuous member. You can use space gas to model that entire plate if you want, uh, with the beams, and also using plate element. If you want, your entire thing can be modeled there, and then change the sizes, and then check deflections for a start, um, and then see what sort of values that you get. Otherwise, that you can also use as the line diagrams in a 2D analysis you can do, either using space gas. If it is indeterminate, you need a software program to calculate and give you the moments, M star and shear forces, because it is not determinant. So um, you can quickly find a flow plate flow framing, which is pretty much a decision making process, and then you do the calculations to optimize computer analysis and things like that. But you have to have the framing plan to do that. Otherwise, you don't know what's the span of the beam, which direction is the beam is spanning, between which wall to which wall. You have no idea. And the other thing is, how come this, where the slab is spanning? So uh, normally in concrete theory teaching, you will maybe finding simply supported beam or a continuous beam you may have designed a couple of them. Slab you may have done a slab design, but this is the first time that you will be asked to frame a flow plate. If you are doing when you come to next year, as I previously mentioned, if you are doing your long span and high rise structures, this exercise will be pretty helpful for that subject as well, which I am doing with you next semester. Okay, here is a normal engineer think which way I can see that both ways. This is not. This is not the. This is not. This is an example only. This is not the necessarily the best one. You can find out better solutions, but the idea is there. Which way that you would be doing. Of course, if you want to do, then you can decide, can you do it as a one-way spanning slab, or should it spans two-way slab? It's essential to do this two-way spanning slab. Just if that may be the case, that is possible. Otherwise, if it become obvious one-way spanning slab, will that be helpful? Um, uh, and then which are the supporting bridging beams? This is shown in these dotted lines. These dark color black lines are basically walls, load bearing walls. So that is an interesting exercise, guys. Then you can see the layout is coming together. We have given here leave 340. Yes, that is what I said, around 300ish. 306, 300, and then in this case, that 3.5 secondary beams are going with a slab. I wouldn't do that. I would try to 3.5 is a very, very short span. Um, I don't think it is that is efficient, but you can try. What's the best that you can get? In this particular example, they started by starting by saying, "Oh, I have to have a." They started with the 630 millimeter deep beam, probably, and 300 from the bottom of that particular beam. You have a 340 clearance so that the uh, services can run. So I have given step-by-step process if you wanted to follow Eurocode, but more important, the steps are there. The simple, now you won't be able to do it manually if it's a continuous beam. Remember, there is a simplified formula given in Eurocodes and every code. This looks like to me the slab design, obviously. Um, so you have the slab is being supported by many members, so you can take a 1 meter strip of a slab and then uh, check that. But in order to do that, either through a simplified method or through a computer program, you need to know what the bending moment diagrams are, shear force diagrams are, and then you know what to do with it. As I said, my interest in this one is not teaching you concrete design, but how concrete design knowledge can be used to complex design problems. Um, there you go, 1 meter strip. So you had to run all the way through, and then see how um, that can be taken. So in this situation, beam is a designed as a simply supported beam, as you can see straight away, using WL squared upon 8. But not all beams may not necessarily be simply supported in your plan, in your uh, layout plan. So the first is when we meet tomorrow um, in the workshops, my main objective is to sit with you guys, type A and type B uh, units designers. They can join us in the first 2.5 to 3 hour session, and with a break, of course. And the afternoon session will be by unit C and D students, and then we can discuss the flow framing side easily. But these are all just examples. So that will help. But this is where I want to be tomorrow design workshop. Now, if you guys have any questions, couple of ways that we can I can answer. If you press the raise the hand button, and I might be able to answer. The other way is to you type a message or question in this. Let me say, yeah, in the in this comments page, say something page, and then I should be able to uh, answer as best as I can. Hopefully, if I can't, I'll explain you why. Uh, if you don't have enough time today to answer, and then I will address them tomorrow class. Um, I will be meeting you then. Unit A and B designers. I think first thing in the morning. I can't remember the time. I have given the time in my Canvas notification. Workshop is like today through Collaborate Ultra. Um, that is the point where you can, while I am showing few things on the in an interactive way, and then you might be able to look into your own plans, and then get an idea how how can be how it can be done. Of course, if you have progress already, fair long way still, you can come and sit down and listen, and then see whether things are good or whether you can improve a little bit. Okay, guys, I think that will pretty much only 15 minutes to go to 7 o'clock from here. And then on your side, it is very close to 6 o'clock. And then I'm happy to answer if you have any questions. If you don't have questions, then of course, that's fine. Any takers? Hello, are you guys there? Okay, good. Thanks, Shu. Yeah, good. I know that you guys are there, and we have about 47 students at the moment as I speak. That's good. We started with 35, it increased up to about 50 or so, and then I saw a few people leaving. So I'm here. If you want to ask question when you're joining us tomorrow morning, get your flow plan ready with a pencil and pen, and as I start discussing about how I would do it, kind of a brainstorming session kind of thing, um, and um then that would be good. Um, and then you can post your, take it easy, because uh, I have I have been doing this subject for fair long time, so I roughly know you guys are uh, uh, what you guys are normally facing at this time of this semester. I am aware that COVID has not been kind, and it's hard for most of our students, but we are here to help. Um, if I can, by when our design workshop finishes, give a decent understanding of how the framing work, um, what sort of spans that you would be dealing with, um, what is the um, efficient way of laying out your floor plan, even doing without doing numbers, with a simple set of rules, and then um, just be my guest, and we should be able to pretty much frame out our flow for tomorrow. This is assuming that you have interior layouts being reasonably done. If it hasn't, if you haven't done it, again, sit there and then get some feedback. Uh, Check few things, whether it's okay. I'm during the class time. I have 3 hours, of course, in the morning session and 3 hours in the afternoon session. You are welcome to join both if you like to, but not necessary. If you want to get sort of a feedback of your floor plan, I can we can chat that, or you can send me by an email or whatever. I should be able to respond to you. If you can mention you're a Hong Kong student, that would help. I am handling large number of students in Melbourne uh, subjects as well. So um, yes, that's where we are, guys. If you don't have any questions, I may say that it's been a good 3 years, 3 hours. Sorry, pretty much. We have 10 more minutes to go. My email is, thank you for asking. Guys, you can write down my email. Um, it is Saman, SAMAN dot Desilva, DESILVA, at rmit.edu.au. Let me see whether I can type it. Thank you for asking that question. Okay, how would I say? There you go. Can you see? Can you see, guys? It is rmi saman.desilva at rmit.edu.au. Okay, excellent. Thank you, Kim. Thank you, Chun. Yeah, yeah. Do feel free to send me, but just mention that you are a Hong Kong student from one CIV 1156. That helps me to really identify. Um, yeah. Apart from that, I used to come to Hong Kong and teach this subject. I will stop recording now. Um, um, I used to come to Hong Kong, and then we used to sit down and work out these things. But unfortunately, COVID situation doesn't allow that to happen. So don't be shy. Ask any question if you like me to answer, and we'll take it from there. I have set up the Collaborate Ultra link for tomorrow, 2 workshop classes. So it's just a matter of you getting into that. Sorry, let me. I saw a message, but can't see from here. I saw it is popping up. Da, 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 da. Why can't I see it here? Ah, there you go. Yeah. Okay. The question is about the passive design. How architect concerns the passive cooling by reducing solar um, insulation, while a good design encourage using daylight. Um, it is very interesting question. My answer to do is um, passive cooling. When you're when you're talking about um, in certain part of the design, of course you're depending on your window directions and which direction that the window is facing, whether daylight is really strong. Say for an example, you are facing the west side, and then all the time during around 2 o'clock it is hot sun, it is streaming into the house. The daylight is there, but it's a much uncomfortable situation. So you have to put the AC on in this situation. On the other hand, you can have a situation that your daylight is not necessarily strong enough. So in that situation, you can actually use a larger window to try and capture it. There are some passive ways of doing this as well nowadays, using a light sensitive glasses. So it works as a sunglass, or it gives the right amount of light. You can also do it. You can do it using um, lures, which can be at a particular sunlight intensity. A sensor would kick in, and then the lure will be adjusting the lights. It depending on which room you are in, how much of daylight you want it to be comfortable with. Of course, if the daylight is not good on a rainy day or a cloudy day, then you will be switching on light. But if the daylight, you have put your windows, large windows, in a sense that daylight is going to be a real problem towards the west side, because it's becoming very hot, and then that is a lit that is something an architect or the designer himself will consider. uh, I'm not sure I have answered your question in full. Can you let me know whether the answer is acceptable, or you want to ask more? You want more explanation, or at least have I understood your question clearly? Can you give me a feedback? Yeah, right. Okay, I'm glad. So yeah, we can control the whole purpose of the architect or a designer involved in this is that we get the best outcome from the nature. For an example, if as I said, if you wanted to invite morning light inside the house, which is you have a room or something on the east side, I would put my family area into that area, and then put the put a large window in that, because I'll be getting morning light. It will be beautiful. But if I have uh, a west side wall, and then if I am to put some windows there, at least to get some good enough daylight, I will be having a smaller set of windows. And then even those small set of windows will be having some louvers which can be adjustable for the required daylight sunlight. Because at the west side, around 2 o'clock or 1 to 2 o'clock in Hong Kong, it's very, very warm. And if it is high humidity, and then of course you guys, almost all houses have a air conditioning. Your air condition will be really working hard, and then you have to put it all the time. That's a very, very important, good question. Actually, sunlight is a fantastic comfort, uh, as well as can be under very hot, warm summer days with large windows. It can be a bother as well. But there is a way of doing improving that. So, may I know, what do you think about direct cooling system for air conditioning? Okay, yes, there are a number of different types of cooling systems are coming. Air conditioning is the one which is the uh, most environmentally, nowadays. Of course, the efficiency has improved a lot, and also reverse cycle air conditioning is also there. But there is another cooling systems. I don't know whether the you may be asking district cooling. This may be a trade name, but here what we call the evaporative cooling, uh, which is um, which is a system which draws air from outside and then cool it through the water cooling system, and then sending it inside. So what the air conditioner does is it in, it decreases the um, relative humidity. For Hong Kong, I'm not 100% sure the normal uh, evaporative cooling systems, which I'm talking about, it cannot get rid of the humidity down, but it acts like a wind inside the house, as if you'll be sitting in front of a cool reservoir or uh, um, in the beach on a cool day. But the problem in climates like in Hong Kong, not only it's hot, but it is very humid. You are sweating all the time. So in that sense, what the air conditioner does is it actually drops the relative humidity in the room, and that is why air conditioners are popular in uh, in places like Hong Kong and even Sri Lanka, India, for an example, where the relative humidity is around 80 to 90%. Whereas in countries like Australia, our relative humidity is around 40 to 45. So we are not sweating. Even though in a very hot summer day, if we are burning ourselves in the sun, but we are not sweating. So inside a house, one of the most important criteria in a tropical country, tropical setting, closer to the equator, reasonably close to the equator, even here in Brisbane and north of Sydney, very similar, uh, is the relative humidity plus this direct sun is the problem. It is not a problem, it is a discomfort. Oh, did I explain it all right for the question? Did I understand your question? Yes, I'm. I am. I understand this one. This is a. um uh, I heard about this project, but I'm quite frankly, I am not 100% clear about how much of energy is being required to chilling the seawater, uh, and whether it is a very good project with a very good environmental uh, scoring, or uh, it is relatively better than that of the uh, ACs providing by each house, maybe. If you consider each house is using separate air conditions versus chilled seawater, cooled airflow, very similar to the evaporative cooling system which I was talking about. In that situation, it may be better, having a better environmental footprint. But you have to compare all this to be sure that is the this I only read about this one. I have no idea what the details are. Uh, but I am not surprised. Say for an example, here in Australia, I'm using a cooling system called evaporative cooling system, which can be used with the pump or without a pump. The one when I put it to the without the pump, sorry, with the pump, what happens is that the air is taken from outside. It is cooled by the water, home water pumping across, and then it is a cool air pumped in. We are not sweating even on a hot day, as I said, because the humidity is not high, so there's no problem. But I believe if the I have never in a place to answer your question where the relative humidity is very high. The, and the other one is evaporative cooling system is also can be used without the cooling. When the relative humidity is higher here, I normally put it without the cool air cooling. What it does is it evaporates the sweat from me, and that makes me feel cooler. So there's this cooling system has two different methods. I'm not sure I'm talking about the same product that you're talking, but it's a very interesting question you're asking. How many people are served in this district? How many people they are servicing? It's okay, guys. Thanks for hanging around. It's almost 7:06, so I will hopefully sign off. Hello.